Conditions for constructive and destructive interference. This is very important topic. Now let us derive what are the conditions for constructive and destructive interference. Now we know that for interference the essential condition is the two sources should be coherent and that should have the constant phase difference or no phase difference. So let us consider we have two waves, y1 represented by a sine omega t, where a is the amplitude of first wave and omega t is the phase angle, and y2 is given by, this is b sine of omega t plus phi, means the second wave is having amplitude b and it is leading the first one by a phase angle of phi. Now according to the superposition principle, y is equal to y1 plus y2. So adding these two, we will be having a sine of omega t plus b sine of omega t plus phi. Now using the relation sine a plus b is equal to sine a cos b, I am writing here the formula sine a plus b is equal to sine a cos b plus cos a sine b. Okay, so in that case we will be having a sine of omega t plus, this is b, sine a is sine omega t, so we'll write here sine omega t, sine b is cos b is cos phi, this is cos phi, plus then cos a is cos omega t, and into this is sine b which is sine phi. Okay, so from here these two terms sine omega t can be taken out, so we took sine omega t out and we are left here a, and this is b cos phi plus this term can be written as cos omega t taken 1 point and b sine phi. Phi terms we take the separately, b sine phi. Now we have to need a equation which would be either in sine or cos, so we are converting this formula in that form. So assuming that let a plus b cos of phi is equal to r cos theta and b sine phi, this phi term b sine phi is equal to r sine theta. Putting these values in this equation, y is equal to sine omega t r cos theta plus cos omega t as it is cos omega t, and b sine phi is we will put r sine theta. So we take r common from this, we will be having sine omega t cos theta plus cos of omega t into sine theta. So you can see here this becomes the formula of sine a plus b. So write here r sine of omega t plus theta. It means when two waves having amplitude a and b superimpose upon each other, one wave is a having amplitude a and another wave is having amplitude b, suppose, then these two superimpose to give the resultant, which is again a sine wave having resultant r. Okay, and that is changing by the phase angle of theta. So this is our resultant wave y. Okay, so now give it number 1, this is 2, this is we are having, this is 3, this is 4, and this is 5. Now squaring and adding 3 and 4.